Okay, I got a new tool in here. This is the Jim's depression release drill fixture tool. There's all the parts are in the box. Some of that stuff's in here already. So I just read the directions on how not to do it. So this is for twin cams only, they claim. So here's some twin cam heads. So this basically comes off the dowel holes here, which you have right here. It's 2 dowel holes. You got the mounting hole to hold it down for 2 bolts there. You got 2 different bushing locations depending on which head you're on. So they say don't use a hammer unless you have to. So I'll use my hand. So one of these 2 holes is the one you're going to put the hole through. So if you put it through there, the spark plug is going to get in the way. If you go through here, it's open territory. So they got a drill bushing that goes in there. These are called drill bushing because they're heat treated bushing that you drill through. Pretty complicated name there. So that will put the drill right down here where you want it, instead of in here where the spark plug is over there. This is the combination drill spot facer that they use. So it goes in there like that. You can see where it's going to drill right there. Versus this one, if you go over here, it's going to drill right through that spark plug hole, which is where you don't want it to be. So it goes in there like that. I'm going to put a hole right through there. Now here's a used head I got. It's already got one stuck in here, so we got to see if that's what's done with this tool or not. Probably was. Okay, so this has a stop bushing that you're supposed to put on here so you don't drill in too deep. So you're supposed to drill down until you hit here. This you're supposed to hold on with a set screw over here. And of course, as soon as you hold onto a set screw on a nice machine surface, you put burrs on it, and then this nice smooth hole that doesn't have a lot of clearance in it, and it'll be very hard to get it out. So what you do is you put a felt tip marker right there, you mark it, you stick it in there, you put the set screw in, and you go back and forth and mark it, and you come back, you grind a big flat spot right there, so you don't damage your tool. Just like these drills have flat spots that you tighten the set screw against, see? That way you don't know damage. You'd think they would have figured that out. Alright, so this works on front or rear head, obviously. Now, they say you can't use it for an Evo. We got one right over there. Bet you can. Alright, so this one here already got a hole in it. Right there. So let's see if they use this tool or not. It appears that they use this tool. Goes right all the way down. So this is it's deeper. It's cut down deeper than what my stuff is right here. In instructions, they tell you to go down until you clean and then stop. There's no reason to make a big ass hole like they did. Here's your compression release. So there's no reason to make a big hole. All it does is collect dirt, water, and muck. So basically this is what we're going to be doing, except I'm not going to be so deep. The other thing you talk about is they don't want you to go more than too deep, because then you'll have too thin of a head. Combustion chamber thickness on this side from the hole. So they want you to be about 200 to 250 minimum thickness. So I put my drill in here like that. Went in to see how deep it was from the other side, and I came up with about maybe that much. So even though they drilled a little deep, they do have the minimum number that you need. But if I pull that back up quite a bit, it won't be that deep. So as far as I can tell, they went a lot deeper than needed. about 3/16 deeper there. So can't think of any reason to do that. All you do is make all these other things thinner. So I don't know. Doesn't matter how deep it is because it's just a hole. You know, when this opens up, air goes to that little small hole. It doesn't matter if that hole is an 1/8 inch deep or an inch deep. Makes no difference. Or thick, I should say. All right, so this head here is a good head. This one here has the factory compression release in it. This is an 06 casting. If you look on the part numbers, you can see there's an 06 in there somewhere. Right there. There's your part number 06. Now, the easy way to tell it, because it's hard to read, and if it's on a bike you can't tell, can't read that. So on a stock head, if you can put your 2 fingers in there like that and go in the hole, it's the late head. If you can't put your fingers in there all the way, it's the 99 to 05 head. That's how you tell real quick. Now these also have conical valve springs in here, or beehive. These are actually beehive. Conical will be straight taper. So beehive has the metric stem in here, 7mm stem. The early heads have 5/16 stem. This one here is probably an early head. Yes, it is. See the hole there? See the hole there. 2 fingers go in there. 2 fingers don't go in there very well. See, lots of clearance. Doesn't fit. Now, I tell everybody to buy the 06 casting head if you want a performance job, because this head comes stock from the factory with Evo type ports in it versus little dinky ones they use in an early head. Now, this is a stock Evo motor here, and you see how the port has a big hole in it. Okay, same as that. Now this still has a bigger valve in it than this head over here. This is a 100-inch motor plus. This is an 80-inch motor. Obviously, they don't need as big as ports they think they needed, or they were trying to mix low RPM motors, which is what they were doing. Evos are made to run fast. The intake valve is bigger also, and the ports here is about the same between the 2 of them. The intake port here, my precision measurement device here. See, it's about the same. So they use the same size port, same intake manifold, smaller intake valve, smaller exhaust valve, and roughly the same size exhaust port. So that increases your velocity, which will make more low RPM grunt for people that want grunt. So the other big improvement was on the twin cam was you don't have shrouding like this one does. That really shrouds the valve. This is unshrouded, it flows a lot better. That's one reason why a twin cam will run better than Evo, within reason, because it's, even though it's a smaller, it's a lot bigger motor too, which really makes a difference also. But, so anyway, what I do is I take these and I cut these out to about here, put big scallops in here, and that lets them breathe. Picks up the power quite a bit. Kills a little compression though, but we don't care about that. Alright, so this is an early head, that's a late head. This has 5/16 guides and stems in it, valve stems. These have 7mm. But the beehive spring has an 04 number on it. So these might have came out in 04, which means they would have this type spring with early guide. I don't know if they actually didn't use that spring until 06 or they had mixed match stuff. So I haven't taken apart an 04 or 05 bike to know for sure what they did that I actually know is that year. So I've never seen these spring setups on the early head stock. So maybe they didn't use it until 06. Don't know. Okay, the factory compression release has a big hole in here. So there's no reason to have a hole over here. Unless you want to plug this up and go to a mechanical instead of the electric one, which you might want to do when these fail. Who knows? They do fail. So anyway, that's our options there. So we are not going to be modifying this head. This is going to be our test head, because this has a broken exhaust stud and a screwed up flange setup in it. That's what happens when studs break off. So this is basically a junk head. So I'm going to go practice with this. You can already see that it works because there's one right here, but I'm not going to go that deep. So that head is not going to be used for that purpose. Okay, the next thing is our Evo head. I need to do a set of Evo heads. So this is the only Evo head I got. So I guess this is going to be the prime candidate test. So Evos have the same dowel pattern here as the twin cam. So that tool will fit right on here with no problem. It also has the same bolt sizes here and here. So the bolt fits in here too. See, it screws down. So that's the same. So even though Jim says they don't make a tool for the Evo, back in the day, I remember there was a tool for the Evo. I think it's the same tool. So just sits on there. So if that doesn't screw in, you're on the wrong one. Go to the next one. Oh, there you go. Now you do realize these fancy numbers they put here will disappear after you put washers on it for about 100 times. They should have put the numbers further down. Or letters, in this case. Okay, so that will bolt onto that. So, next question is, what's going to happen here when you put this in here? For some reason, it looks like the spark plug is in a very similar location to a twin cam. See? Imagine that. Harley doesn't make a lot of changes. So even though they don't say anything about using this tool for an Evo, it looks like it will fit an Evo pretty good. Now the only thing we're not sure about is what's underneath. I'm not exactly sure where this drill bit's going to come out at. Seeing how that this other head was already done here, I have a pretty good idea where it's going to come out now. You got to remember it's cut away over here quite a bit. What angle is it at? The angle it is at is that angle. So there's a big hole right next to that valve seat, right down there. Now these have small valves. Now when you do a performance motor, like this one, this is an S&S head. They have big valves in these things. Guess what's going to happen? This little hole right here is going to go right next to that valve seat. And the big hole that's under it you can't see is going to be taking some of the valve seat holding away on these big motors. So that, it looks like it might be a problem. What I would do, I think, is I'm going to take that and move that thing way over to here. And all you got to do is take this fancy tool they got right here. Instead of putting it here, I just went back in the same hole. There we go. You move it forward a little bit. So you figure how far you want to move it forward. And center the hole, we can move that thing forward 150 thou and still be in the combustion chamber down there. But nobody says that hole can't come out up here, which means if you move it over a 1/4 inch, you'll be right at the edge of that chamber. If you move it about 300 thou, you will be well into the head over here. A long ways from any kind of big fat valve seat. So instead of the compression release being way in here, where's that head? Too many heads out. So instead of this sucker being way over here, where it's getting close to the spark plug hole and all that, and there's a big plug wire sticking through here, hard to get to, you move that thing way over here, and that will probably be a lot better. Now there is a fin down there, but you can already see they cut into the fin and hit more material underneath. Now it just comes to a matter of how much fin do they have down there, how much material is in there. So you gotta look through here and figure that out. So eventually you're gonna run out of material for the head. It's hard to tell how deep that is. Yeah, right there. So the fins are all about this deep here. That's on the bottom one. Top one, see it goes right through. So all I care about is the bottom one. So as long as we don't cut through the fin too much, you should be able to move that thing out a little ways. I don't know about moving it out a 1/4 inch, because see it is kind of hollow up under there. You're going to cut through at some point. But either way, we need to move it out at least 1/8 of an inch minimum to get more thickness in there for big valve seats. Otherwise, you're going to be coming in the side of the seat. Now that's also true if you got 110 heads, Scream Eagle 110 heads. Any Scream Eagle head that has big valves in it. And they got 2-inch valves, and they make 2 1/8 inch valves for some other applications. Evos have 2-inch valves. You have an S&S motor. So you have the same problem you get into the things. So we can come over here quite a bit on this chamber because we don't have that flat spot. So we still have to see how thick we are in here, but it looks like we have about the same kind of problem. But you can see how the second fin on this is a lot thicker than the top one. So worst case, you spot face through the first one to get all the way down. So basically going to have to experiment. So you got to do a couple heads and get an idea where things are at. But this is going to be a problem on big valve heads like this. Now you won't see the problem because it's behind the valve seat. But the valve seat will not be really held in really good if you come in the back side of it. If it's really a big seat, you'll actually cut into the steel, and you'll see that in the chips. But, so yeah, that's the problem there. So I think this needs to be moved over at least 1/8 of an inch. And I'm thinking more like 3/16. It'd be the magic number. But it's going to be hard to tell. Like I said, you want to get closer over on this chamber, but we don't want to be right up on the chamber. So, like I said, 150 would be fine. I don't think we can get up into this area because we'd be too big. But we do need to pull it back. So that's where I'm at. I'm going to figure out what we can do. But I don't see a problem doing on Evos. It's just a matter of where you come in at. Like so, the stock valve sizes, I don't think there's a problem. It's just when you get into the big head, the big valve seats, that's where the problem comes in. Because it looks like they got this, everything's going to be in the same relative position. It's just further, it's just going to be real close. So, see here the seat is flush with the spark plug a little bit. See on this one is, see how the seat's way on the edge of the plug out here versus this one here on the intake. It's not even quite in the middle of the plug. So right off the bat, we need to go over 200 thou to have the same thickness here as we do there. But I don't know why you have to go that far. The seats aren't that much bigger. It's 1950. And this seat is 150. 200 thou bigger. So if you move it over 100 thou, you should be the same thickness as this head. So we gotta move her at least 100,000. So I'm thinking maybe 150 might be the number we need to be at. Like I said, that's for a 2-inch valve head. Now if you go to a 2 1/8 inch valve head, you're gonna have a bigger seat yet. Then you need to go even further. That's when you need a 200 thou offset to make clearance for the bigger valve. Bigger valve seat. So, yeah, those are all things I'm going to play with a little bit, figure it out. Initially, I'm going to go ahead and cut the head and see what happens. I think this is going to be in the same spot. So, if I modify my tool, I already got one that goes in the stock spot. That's the one that's already done. That's this one. So, I don't need to duplicate that. What I need to duplicate is moving it over some more. So I think we need to go modify this tool a little bit. So put that in the milling machine, kick it on over a little bit with an end mill, and then we can reuse the tool by moving it over like that. So I don't know if I can get away with 200 thou movement. So, but we do have a junk head, right? One of these heads. Which one was it? This one's a junk head. Yep. So I can do this head and see what happens. Worst case, I can always fill the hole back up and redo it. Thing about making tools, you can modify things. And the dowel pin, instead of being in a tool here, I will be putting into the head. And then I'll put the tool on top of the dowels and slide it over a little bit. So it'll be slightly modified. Alright, I'm going to go play this a little bit. We'll be back.